I'll just take the lights down for you.
Yeah, thank you. So, I want to start with this interesting question because well, actually I'm very glad that Severin also highlighted already the importance of why are we doing this, right? So we want to actually use openEHR for research, right? And whereas he explained the why, I think I can explain the how. Right? So what do you need inside of our open system to be able to actually use it for research? Because in the end, most of the queries that will create and everything that you will try to do is quite hard, even for relational dependencies. So I think we can even do better than them. So very briefly, I will again try to compare. So get like the gold standard right now, that's SOMOP, right? And try to see what is the SOMOP that we cannot do or we can do, right? And then I will present 3 key results that I think that are the key things that you will need in our open system to actually do research in openEHR, right? So, as you know, already the real world research is actually the research that's coming from EHR claims, and more and more is being proved as being valuable, and is supporting really large scale studies. For example, the OMOP is covering like 40 centers studies, so it's really interesting to have. It's also very cost efficient because once you have this kind of research database, you can use it for multiple studies, right? And I actually use for rapid response because you can like design a study and then run it over your data already. And also, as it's coming from EHR, at least you can use it for even personalizing medicine. So, as I say, in this world of real-world data research, OMOP currently I think is the gold standard, and I will tell you why I think that. So, what I can from the background of being like involved in 10 different or more projects, and one thing that I actually started to think about is, even for the start, is like, why are we doing this kind of ETLs to extract data into OMOP every time and again, when we already have probably most of the things already available there, right? That is like I'm already making mappings for things that are probably even better in the source data, in case of openEHR, right? So a little bit of OMOP key points that I assume that everyone knows the OMOP. OMOP is usually extracted from the sources, right? You get like a usual system, and then you get the data out into OMOP. OMOP has a standard model, a standard vocabulary, right? That's the powerful thing that everyone speaks the same thing. Usually they have a easy time like having queries and sharing the codes. That's actually very important too. And of course, they have the discovery network where it was involved, and they have lots of open analytic tools, right? So I think that these are probably things that we should achieve to accomplish if we want to really create like a real open network, this network. So in general, using ETLs for getting data from the systems is difficult, as Ian said. Usually the source data is a mess. It's really not well like defined, that has really big data quality issues. So when you are doing ETLs over that, you get lots of context, lots of semantics. There is consistency in data quality. There are things that are very well defined, others are like really garbage. And you are losing like this kind of unified view loss that you are getting from different parts of the system, right? And I really believe that using openEHR, I say completely avoid, but probably minimizes like 90% of the problems, because in the end, the most one is that you really don't know what is in the data, right? And you really need to know really well the source data to actually create a map into any kind of research. So, what do we do in openEHR, right? In openEHR, we have a very critical research model. We have a really semantic description of the data in the forms of architecture templates. We actually have a development model, but it's kind of there, but we could use that too. And again, we're actually trying to see how we can actually access demographic data into a query, right? That's something that we will need for sure if we want to do research in openEHR. In terms of vocabulary, openEHR doesn't really mandate any specific vocabulary, so that could be a problem for research, right? In general, you can do this kind of bindings for whatever terminology you need in openEHR. But again, if you are doing some kind of federated approach, we need agreements. That's something we will agree beforehand to say, okay, we need to use this kind of terminology, or at least have the mappings that openEHR already support, right? So if you are in a ecosystem that will need Snowden mappings, then you will have to create at least 10 mappings to Snowden in your data. So we can actually do very powerful things in the openEHR space. For example, we can call like terminology queries in the SQL directly. So some kind of expansion of value sets, or even checking some kind of ECL, saying give me all the diseases that are caused by a virus, for example. You can say that in ECL and try to get data from your system, right? So that's very powerful. That's something usually you get in the SQL-like research, that you are limited to, okay, I have the hierarchy in SNOMED, for example, and that's it. Or I can do like this children of this, except these ones. So you're limited to that, but in general, you could in theory, in openEHR, send any query to the ECL and say, okay, give me something, a very strange question, right? But again, these kind of queries are very powerful, but are very costly. I mean, some queries could be like 30 seconds to execute, and do that for each one of the patients could be very time consuming. Another thing is about OMOP. OMOP has the concept of cohort, right? And Sevin already talked about this a little bit. Cohorts can define by the equal query that generates the patient, right? You can get, okay, give me how many patients that have this condition, and that's actually an equal. We could kind of get, okay, I know this patient, so I will get the IDs and take it into the demographic server and get a group, for example, of patients. We probably need some metadata that is not still there. We could go back to the FHIR demographic server and say, okay, yeah, this is a group of FHIR. We could even use tags, but probably it's not really a good idea, because in the end tags will create like hundreds of new tags just for each kind of one of the studies you create. So that's probably, I mean, at least the query is there, and is the thing that will be really shareable. And one thing that we can do also is, again, not the query itself, but the data will be needed for the study, for example. That could be actually the definition of the core, right? And I think this is a very important thing that we have to take into account, because in the end, these archetypes will be the ones that will be like getting the patients. You will say, okay, which are the patients that are included in the, I don't know, study about whatever, and that archetype itself is the cohort, right? We usually call that abstraction archetypes, but I will tell you a little bit why we need data and why it's important. So this is actually the first result. I think we will need this kind of abstraction archetypes. Usually there's like kind of a mismatch between what you have in DHR, for example, and what you are doing research or even clinical support. For example, you will say in your data, this patient has a type 2 diabetes in obese, for example, and that's a very specific code. But for example, for research, you say, okay, the patient needs to have diabetes. And that's kind of a mismatch on what you have, right? So this kind of archetypes will give you like the answers are actually what you're going to check, and then you have to check that beforehand, or when the patient is diagnosed, then you say, okay, yeah, I will create like a type 2 diabetes, but also will create a stance of this kind of practice, patient has diabetes, right? So you create both at the same time, and that's the thing that you will check then. Yeah, so this will use for generalization and try to match, and then the idea is that this query will be over that archetypes. And I think, for example, we already have some kind of archetypes already that are actually abstract archetype. For example, some indexes, some like Charlson index, Diacritics, etc., are really just interpretation of data that is already there. It's saying, okay, this patient has history of diabetes? And it's yes. So that's the kind of question that you will get in this kind of abstraction archetype, right? So again, we don't want to run this kind of query to every user in the repo, because that will kill the system in no time, especially if this is like a central CDR that you don't have like really like control to actually run this query. So the idea is that we can use other archetypes that are already available to create this kind of instance of probably a persistent instance of this archetype. For example, if we know that we have some kind of history archetype of cardiovascular disease, we could create automatically a Charters lineage for that. This is also true for other kind of sources. For example, you could say, okay, I know the patient, the last time he came to visit, he was 35 years old. And that's probably enough data to not try to say, okay, what is the current date of the patient when I run the query? Because actually, this kind of things is like, okay, I know that it was true when the patient came, but I don't know nothing about the patient when he left the thing, right? So the idea is that at least you get all the facts that were true at least the last time you see the patient. Also, this could come from NLP, for example. You could say, okay, I know things about the patient that come from natural language processing, or even public data, for example. In the recent case of Valencia, you say, okay, what are the persons that were like in the zone of the catastrophe, for example? That's something that you could say for the data for like where the person lives, for example, right? Or even like some kind of like environmental information, right? So one thing we also have to do is try to ease this kind of research queries. OMOP has some kind of the derived tables that you actually generate when you create the system, are like condition errors and drug errors that are actually for this condition, did the patient has it over this period, and that's like answered by this. It's not like I have a condition now. It's like in this range, I assume the person has the condition, right? So that's more the thing, or the drug was administered. Also, it has the meaningful thing that observation period that is actually when I know the patient was already in the system, or if I know that the patient left the system, I probably cannot make assumptions of that, right? So in openEHR systems, probably is like perfect because we have like the lifelong record, right? But probably in some like not full records, like hospital records, we can just assume that at least for the time we saw the patient, that's true, but we don't know if he went to the hospital, right? And again, we need to get these queries, as I say, probably from other systems like demographic systems, or even we for example say, okay, I know there is a relationship in a fire demographic server from two patients, though I can say, okay, this son has the parent that had cancer. Then I can create like, okay, this kind of abstraction archetype can say, okay, patient has a family history of cancer, right? So, but those will require go into the other systems or even other like fire systems. This is not really like the final query, but you get the idea. Like the idea is that you will need at least this kind of grouping that is only supported, I think, by better. I don't know if anyone else supports it, but the idea is that you group a diagnosis and then you say, okay, this is minimum time, maximum time. You put that into a specific like abstraction archetype, and then you can actually check for a specific condition if the patient had this condition in a specific date, right? And it's easier than try to do queries and queries and queries. The same for the drugs. So the idea is when some event happens to the patient, then you can say this to the system, create this scale, create this add this to the specific conditions, give me the correct EHR offender, and put that also into the EHR, right? So it's easily like pointed by these queries, and you don't have to actually go back and do all this kind of really heavy queries. And actually, using this kind of abstraction archetypes, really eases the things like dashboards and so on, because you are actually looking for a specific values of the archetypes, and that's really super fast. And you can do counts on that super fast. You don't need that. Again, you don't have to do again all these queries to try to get the data. So another result that I think that we can at least take advantage of is that how we can represent cohorts. As we said, we can describe that in EQL, but again, the kind of gold standard are the more published scores. I will show you one right now because it's quite very interesting. The idea is that you have, for example, this is an actual query of an actual cohort in Atlas. It's used for COVID vaccine in the studies they did. So the idea is that you have some initial event, and then you start defining other kind of like events that happen with a time relationship between them. So you say, okay, I will run. So the idea is that you have this kind of a line, and then you get like when the patient enters the cohort, when the patient exits the cohort, you get different classification criteria, and you put that into a query, right? So what we can do is actually say, okay, the typical use cases for cohorts are the conditions that are the problem diagnosis in openEHR, the procedures that are the procedures in openEHR, right? And the expressors to drugs that are actually medication and clusters for openEHR, right? So what we did is we created an automatic transformation from the OMOC cohorts that were like in JSON to EQLs, right? So, for example, we get this kind of, this is not a clinical valid cohort, but you have a female patient that has asthma, who has more than 65 years, has atherosclerosis between 21 and 40 years, blah, blah. And then we can get that into an ultra mega query, right? so that's what we can do. So with this, what we do is really, you can get any kind of query that's has been already created for these OMOP studies, and use that as a query for your system, and you will use that as the patient that you need to treat, or the patient you have to extract data from, or whatever. Right? Again, this is actually using a terminology function, so I will say that this query probably kills any kind of system, array system, because like 40-minute queries trying to do things with demographics too. So, but again, this is automatically created. Right? It doesn't need nothing much else, but again, could be like killing anything. I think we also, this has been commented before, but we think we need some kind of common package definition for openEHR, because in the end, you will need this kind of, okay, I'm using these archetypes, these templates with these parameters. I'm using this SQL query, or I'm using whatever. Or I'm using this, some kind of ABAC for, this kind of thing that will be to go for different systems. I say, okay, if you want to participate in this study, you have to use this query, use these archetypes, but everything in a package. And I think we have to actually work on that. So again, this should be scalable and so on. That's more or less the same things. As I say, this could be get really complex, very difficult, and really fast. And again, there are a lot of lacks in what you can check if you are not really doing things like with external services. So again, we need something to actually do this kind of querying of this kind of good things of terminology, inference, and so on, and do it like in an efficient way. So I think the first and maybe most like future kind of resource is trying to do that in a knowledge graph. And what we mean with a knowledge graph is that you get the data that's like important, data points that are important, like again, probably conditions, procedures, and medication, and you put that into a graph database that joins both clinical data and terminologies. Right? So the idea is that the queries for that are easily done, saying, okay, give me all the patients that have this kind of thing. It's like getting a node from a condition. For example, you could say all things that you want, like here, like again, some conditions of the hair and give me all the patients that are linked to this, or things like I know these drugs are conflicting, so give me all the patients that are linked to this. So that's really easy to do in a graph database. For example, this is like, give me patients with structural disorder of hair. Okay, and you get like a bunch of HIDs. And we can use it for other things. Yeah, I'm finished already. You can use it for other things like knowledge discovery. So, okay, you know how a patient looks like in a graph, so you can look for similar graphs. You can check easily for cohort. You get two cohorts and say, how does that like merge? So that's really easy to do in graphs. And again, you can even use that for a kind of a proxy between the standards. For example, you can say, okay, I have data in Fire, I have data in openEHR, and really you will have like EHRs that have that, but you don't really care if they come from one or the other, right? So with that, you will get this kind of cohorts in the graphs themselves, and then get the IDs and use them for that. So finishing. I think that using this kind of AQL cohorts and queries based on archetypes is really powerful, and I think we should really use it because I think it's the same point for openEHR in this case. And I think the abstraction archetypes are really useful to have, even if like sometimes we'll be like replicating information, but in general it's like abstract information, right? It's like something is there, but you want to easily access to it. And again, we can like send the same abstract archetypes and say, okay, yeah, this is your study, use it, and then give me back the data or the counts of the data. And again, we could use, for example, the knowledge graph to just say a query, get the HRIDs, and then use it in a query itself to get the data or to get all data of the patient or generate on a mobile or whatever. Right. So yeah, that's it. Yeah, too much low level. I mean, I went really deep in the system. So.
Any questions?
Yeah, sure.
Yeah, you talked a little bit about the performance.
Yeah.
One thing, we spoke about this before, is one theoretical advantage of OMOP, because it's relational tables, is the performance if you have many parameters. And this is, we have seen in AQL that it works okay up to 7 parameters, but I don't know where the bottleneck is. Like, is it at 8? Is it at 20?
Yeah, as I
What's
say,
your experience?
the OMOP cheats a little bit because, as I say, there's like derivative tables that are actually doing the hard work there. It's like, again, the drag era is like, you're not really looking for data points, you're looking for pages of time that patients have something.
Yeah.
So that is a lot the queries and is making the things very, very easy in comparison. So I think when we are in a similar position, again, you will be using these kind of parameters. You are not really looking for like overlaps of things. You are looking like something is in there. That's way, way easier. Yeah. It's like you are not doing joins, you are doing less.
Yeah,
yes,
yeah.
Yeah. Yeah, sure.
I come from the clinical research perspective.
Mm-hmm.
I'm a bit curious to know what is going to make me want to abandon OMOP or any other methodology in favour of replacing it with this.
Yeah. Well, I'll question. So I think the main one is when you have that we actually done is tooling and analytical tooling that can really dig into this, like overstack openEHR, not just getting like again the HRIDs, getting the data out with this kind of OMOP openEHR to OMOP process is and then using OMOP. It's like when we have analytical tools over the openEHR like platform. I think that's doable, and I think that's what you will make you don't want to go there, right? Also, another thing is that in general, you could be able to participate, for example, in a OMOP study. As I say, in general, you will get the OMOP cohort. You could execute that, and for example, generate, you need like a specific database for OMO. That's something you can do with this kind of approach already. So the thing is, when you have this kind of analytical tooling, then you will need anything else. But in any case, if people is doing OMO, you could still be able to do OMO. But you could do much more, because you are actually attacking all the data with all the context and everything. Right? So that's I would say that's the takeout. If you are really doing more advanced research by using all the data that is available that you can do, then you probably need this. But if you are just doing OMO, you can actually do OMO already with this too. I mean, extracting the data is like the easy part of that.
But I think that the answer you was looking for is that at the end, OMO is just a subset of the information.
Mm.
What we are proposing here is that you can query all the information of the EHR, not just the subset that OMO says that goes into OMO.
Yeah, for example.
That's the main.
Yeah, I'll tell you.
But of course, most of the work that I would see or be involved in.
Yeah, I mean, for example, there's a bit of regarding to the kind of information that is available in the archetypes, for example.
Can I finish my point?
Sure.
Most of the research I done is a fixed, understood question that requires a subset of the data.
Sure.
So I'm asking, why would I abandon OMO
I can answer that. Yeah.
To this, what research question am I?
For example, one really is like straightforward question. Do you want to tackle the last scale that has been available in openEHR, like version 3 of index, whatever? That's already available in openEHR, and that's not even available in vocabularies, in terminologies, and that's not into OMO. So you can need like custom mappings to custom codes to do this kind of thing up, and that kind of breaks the OMO methodology, right? You need like standard vocabularies. I think that most of the things in the open archetypes are really detailed in a way that you will not find that into standard terminologies, because at the end they are kind of in a 2 year back, so they are not really up to date normally, and they are like half a year later, and then they start starting. So I think that's probably the use case. If you are really interested in things that are now in the archetypes, you can do that. If you are really using like things that are already in the terminologies already, then you can use SWOT. That's fine, because that's there. But in general, this will provide you things that to access data that is in the front-end knowledge. So any kind of cancer guideline that is created and is there and is available, you can use that. But until you don't have this kind of mapping to the terminology or to SNOMED, or SNOMED updates itself to say, okay, yeah, this is interesting, I will put that into SNOMED, then that will be available in SNOMED, and they will be available in OMO. But until then, that's not happening. Yeah.
If I may, sir, how about not having to do data collection?
Sorry?
How about not having to do data collection? Wouldn't that speed up your work enormously?
Yes, potentially.
If data collection would just be a query you could do on a live system and get results in a few minutes.
But that may be the reason for abandoning OMO.
Yeah.
Is because I'm doing research that involves an analysis every week or every period, and I know what the terms of reference are.
Yeah.
But if you're investigating very particular clinical questions, then the curated and clear OMO terms of reference may be the better ones to work against in that sense. I mean, any old, the terminology is always a problem. The semantics is always a problem. So, this doesn't solve the problem of semantics between you and the next thing. But
well, in a way it does, because the archetype standardizes semantics at data entry level.
Okay. I acquiesce to your openEHR knowledge. I'm more from a different point of view.
Yeah.
I think it's important to ask the question because you're asking, you're asking for. I'm not an OMOP fan, by the way. I'm not a fan of OMOP, but you're suggesting that this is something that could potentially replace and potentially improve or potentially offer advantage to those of us who are being asked to undertake research questions against EHR data. And all I'm saying is, what are my terms of reference for deciding that this is the best way to do it?
Yeah, as I say, it means for questions that are actually like in the EHR, you can do that with that. And if you want to participate in OMO, you can still do it with this. I mean, it's just a matter of getting data out of the system, and you can do that already with this kind of mapping. So you can do it either. If you do this, you are not limited to only OMO.
Depending on my terms of reference, I can do it with fire as well.
Mm-hmm. Yeah, why not?
I mean, it's really interesting. Don't misunderstand me.
Mm-hmm.
I think at the moment we're also. Sorry for interrupting. Very interesting.
Sorry. No, please go ahead.
Okay, so I think at this point it's mostly super exploratory work what Diego has done. It's basically saying the world is doing OMOP, now we're doing openEHR to OMOP to facilitate OMOP, and that raises the question, what's the value of doing OMOP if you already have it in openEHR? And that's what the presentation is about. It's not like anybody suggesting let's stop using OMOP tomorrow.
No, but I would stop using anything if mapping is removed from the problem.
Exactly.
That's the
This is the hope of openEHR.
But we're in a world where those methodologies have been developed and have been shown to be of value in the context in which they work. And that's really the only thing I was asking. What would I say to a clinical researcher that comes to me, a statistician, and says, we want to answer this research question, the data is in the EHR, should I go and invest in OMOP to be the source of my data, or should I invest in this case, AQL or openEHR? That's the only question.
And there's one additional aspect, which is that if you collect, I asked before how about not doing data collection, and of course that only works if the data is present before you ask the research question. If you collect data specifically for the research, then you have to do data collection. But one of the downsides of the current approach is that this data doesn't flow back usually to the clinical people. It ends up in the research database, but it's not part of the regular clinical documentation. And if you do the data collection in openEHR, it's much easier for the clinicians to also work with the data and learn from that in their daily practice.
I assure you, we can spend the rest of the afternoon talking about the problems of getting the data a study needs in terms of prospective, so-called prospective studies.
On that note, for the rest of the afternoon, shall we move on to coffee? And obviously this.
Thank you very much indeed for the discussion.
And then back into the main